Right, good morning, the pre-calculus students of mine. This is for, I think, B day here. So I am not at the school, as you can tell. I am in Thailand taking care of some visa business. But today is August 31st, 2022. And this is your first period of pre-calculus. So please do listen to this video, follow my instructions, and then after you watch the video, after you take notes on my video, then you may do the prompts that have been given to you in class. There is a sheet that should be ready in the table printed for you. So please do that assignment the rest of the hour, all right? Okay, so we begin our pre-calculus lesson today for August 31st, 2022. Now, for those of you who did not have a chance to do this yet, we had this sheet I gave you the other day for section 1.2, 1.3 of our first chapter in pre-calculus. So this is going to be what you should have had already. And we did go up to number 9, rationalizing denominators. Okay, so please finish up that where you need to get rid of the square root or any root in the denominator of a fraction. Now, once you do that, you may go on with the rest of the problems. This one, by the way, will be important for today's lesson. Polynomials, I'll remind you about this, but polynomial is something that is like x to the power of 1, x to the power of 2, and so on. Whole numbers only in the exponent, and they should be also no roots, no decimals, no fractions. It's just going to be whole numbers and positive numbers. X to the 1, x to the 2, x to the 3, x to the 4, and so on. And you're going to have multiple terms like that in the same line or same statement, but just make sure you don't have any roots or negative numbers or fractions. Here are some more examples here. Okay, now for these, add these and subtract the polynomials, put the like terms together. All the like terms should come together, right? So finish that up here. Add all the x cubes together, all the x squares together, all the x's together, and any numbers by themselves should be added together as well. Multiplying polynomials, I want you to do it 2 ways on number 11. So if you're doing this times this, right, 2 different parentheses, that 2x can multiply everybody in here, and the 3 can multiply everybody in here, and then you combine them together. If you do the table format, you could just stack this one on top of the other one and multiply each other that way from top to bottom, and then add similar terms to each other, right? And make sure that the x squares should be together, the x's should be together, and the numbers should be together, okay? When you finalize and simplify your expression. Now, for the next few problems, so special product formulas are all given to you in this table. So follow exactly this format like this. You can multiply them out if you want to, but you could just use the shortcut that's given in this table and then apply that to these expressions, all right? So, I mean, for example, 3x plus 5 squared could be, you could do it the long way and do 3x plus 5 times another 3x plus 5, but it's easier for you to just use rule number 2 and then make it look like that, okay? Same thing with part B. And this one, you can use that to help you if you want as well. Okay, so just to make your life a little easier. Okay, number 14, now you're factoring this out, okay? So you want to factor out anything they have in common in each term and factor that to come out and then whatever's left over. Understand? You should know how to do this by now. This is all Algebra 2 stuff. Same thing here. You can write that as 2 binomials, 2 parentheses, right? So that's like undoing a quadratic equation. Okay, and then this one is a special factoring formulas. There's perfect squares, okay, in here. So when you have this, you can expand it out term by term. And the difference of squares would be written with basically the same things, but just a difference of sign, negative and positive. And there's a difference of cubes as well. This doesn't look as easily, but this helps simplify things a little bit for the cube expressions. Okay, so apply this table to these problems here. Okay. And then this one gives you a definition of the trinomial. Okay, so, all right, then you can do number 18 from that. And then be very careful with this one, with the fractional exponents. Okay, so yeah, be mindful of that. You want to find the one that's the least of the exponents here. When you have fractions like that, find the ones that have the lowest number possible. Like in this case, -1/2 is like the lowest number. So you want to get that out of all the 3 exponents that you have. Okay. This is just grouping them together now, similar terms to each other. And that will complete that assignment we did from section 1.3. Now for today, we will go on to section 1.4, because the next set of problems I gave you will look like this. And this is what will be given to you in the class. So please do this one. And then but once you listen to me teach you this first, okay, and then you take notes, then you may do this set of problems, and then that should be your assignment for today. Okay? Okay, so I have a video here for you, so I'll just try to narrate through this video that I recorded like a long time ago, but I think this would be good for you guys to be able to play over and over again, all right? Okay, so we are on rational expressions. Okay, so in this section, so basically we have these fractions, okay? So now I showed you what a polynomial is. So remember, the polynomials are the things that have x to the power of 1 and 2 and 3. Positive numbers only, no fractions, no decimals. Now, a rational expression is if you have a fraction where both the top and the bottom, or numerator and denominator, are going to be polynomials, right? So that's a criteria that you have to have here for the rational expressions, right? Just a second, let me undo some parts of this. Anyhow, okay, so if you look at these, all of these have polynomials in both the top and the bottom, and they meet that criteria for being a rational expression. Now, again, just to remind you, if you had this in either the numerator or denominator, that would not count as a polynomial. Or if you had a negative exponent like that in either any numerator or denominator of the fraction, that would not count as a polynomial. So you could have these either in a numerator or denominator, but if you did, you wouldn't have a rational expression. Understood? That's the definition there. So we'll deal with rational expressions for this section 1.4. Okay, just to remind you with these other ones. If you remember when you did functions in Algebra 2, a domain, and we talked about it the other day, a domain will be what you are allowed to set for your x variable, right? So for example, these are 3 different expressions with x, and they all have a restriction of what we're not allowed to pick for x. The very first one, I'm not allowed to pick x, is a 0, because that would be 1 divided by 0, which would be an error, undefined. And then for the second one, you have a square root of x. We have to keep whatever's under that root a positive number. So then my domain would just be x is greater than or equal to 0. And then the last one, we have a square root of x, and also in the denominator of this fraction. So then x would be limited to be only positive and greater than 0, all right? So keep that in mind for what domain is. All right, so when you find a domain of an expression, okay, you want to basically try to see if there's any restrictions with the x values that you can choose from. So in this case, this first one is a quadratic equation. I don't really have any restriction with that expression, if you know what I mean, because really I don't seem to violate anything. Does that make sense? The polynomial is defined for every x. So then the domain can pretty much be anything. So there's different ways to write that. You can write it like this in the interval form, from negative infinity to infinity. Or you could write it with as real numbers like this, right? So basically, if you remember, I showed that in class before. So this would be a symbol with two lines here and then the R. That's another way to just do shortcut notation of real numbers. And remember, we have these rounded parentheses, so that shows that I cannot include negative infinity or positive infinity, but it goes on forever in a negative and a positive direction. Sometimes you could just write the answer to part A, just write all real numbers, but usually they want you to write a symbol, okay? Instead of just writing it out, but either of these would be correct. Now on part B, I have now a rational expression, not just a quadratic equation. So I have x divided by x squared minus 5x plus 6. So I should find out what are the restrictions with the bottom part of the fraction, right? What makes it become 0. So then I should factor out that quadratic equation in the bottom of this fraction and see what x is not allowed to be, all right? So you know how to factor this. You can factor it into two binomials, right? So remember how to do that. We're undoing the quadratic equation and expanding it out into two binomials. So this is what they are. So x then cannot be 2 and x cannot be 3. Because if you pick either one of these numbers, that would make then this entire fraction have an illegal operation. Understood? And you would have something divided by 0. That's how you write the answer to part B. Right? Part C, you now have another rational. No, now you don't have a rational expression. Okay? Sorry, you have a fraction. But you can still define a domain. Understood? So that one has to be greater or equal to 0. And the bottom part, don't make it a 0. So x should not be 5. So these are the restrictions or domain of this problem for part C. You can write it like this as well. Okay, notation-wise. Notice that I have an and here between this because they're two different restrictions. Understood? Okay, then for part D, oh, I'm adding this one extra just to remind you. Okay, so I have a quadratic equation under the radical. Now, this one is, you got to work a little bit more to kind of show what are the restrictions to this. So again, I have a quadratic equation. I know that, and it's under the square root. So at least you know the square root, the restrictions have to be positive, okay? Now, if you want to somehow graph this, okay, if you want to like write the final answer like you did part A, B, and C, this is a good time to practice using your graphing calculator if you have one, TI 83, 84, 86. So you can type it in as like this, the whole equation, x squared plus 2x plus 2, and then under the radical. And then it depends on which model you have, but you could push the second button, shift key, and then there's a mask button on your graphing calculator that you could push. And then basically from there, you could also push the inequality that should pop up on your screen, do greater than or equal to, and then push the button graph, okay? And then what will happen is the graphing calculator should spit out like two different intervals as the answer to this part D question. And so they'll spit it out as two separate equalities or inequalities. So one is going to be like going up to -2. Just a second, I'm looking at my own graphing calculator, which I'm doing right now. I'll show you in class maybe how to do this, depending on what model you guys have. I'll come around to your desk and see. Yeah, so my graphing calculator screen spits out this one, and then the other one is going to be greater than or equal to -1. So you have it going all the way negative direction, okay, negative infinity from -2 down, and then from -1 going upwards towards infinity, right? So you can write or in this case because there's a break in between. Understand? If this is what your calculator shows you. But try it, guys. Try it. If not, try on some other program or other app on your computer. Okay, so now for this part, we are to simplify rational expressions by cancellation. So basically what you have here is you want to be able to factor out some stuff, okay? If you can factor it out in either numerator or denominator. And from there, you can cancel out anything that would be similar to each other, understand? And then you can make it not as ugly as an equation. So I could factor out the top part, that's the difference of squares. So you could factor that top part into 2 parentheses, right? Do you remember what they should be? If you use that from section 1.3, that we had the difference of squares. Oh, don't do this, by the way. Do not do this. Don't be cheap and like cancel out like that. Big no-no. For those of you who think that you could just avoid factoring, okay? Don't do this. So what you're gonna do is, here is a difference of 2 squares. So this would be a positive and a negative, and they're both a repeat of the same binomial, x plus 1, or should we say x and 1 with this difference of sign. The bottom part is a quadratic equation, so that should be able to be factored out into 2 parentheses as well. Okay, so do that correctly, undo that quadratic, and you have x plus 2 and x minus 1. So obviously you have some similarities. The x minus 1 can cancel out, right? And then all you will have left over should be then the x plus 1 over x plus 2. Understand? That should be your final answer to this first example of a rational expression I want to simplify. Understood? Okay, the next example will be this one. Not as nice. So what I want to do, because this is a multiplication of rational expressions, okay, so I still need to do some factoring, okay, because you have a lot of ugly stuff put together in one thing. But the left fraction especially, I would like to be able to factor that out. So factor that first quadratic on the numerator first of the left fraction. That's what it becomes here. And then on the bottom part, you can also factor that out. That will come out to be x plus 4 times x plus 4. And then the second fraction, you can factor out a 3. A 3 should be coming out of that. So there'll be 3 and then x plus 4, yes. And then the bottom part is just leave it the same way, okay? Now you have some similarities between numerators and denominators of this whole expression. So cancel out the similar binomials. X minus 1 should be able to go away. And x plus 4 as well. And then you will have simplified. All you will have left should be 3 times x plus 3. You want to clean up this expression and divide it by x plus 4. And then voila, you have the final simplified expression. Next one. Now you have a division or dividing rational expression. So basically, you will want to maybe make your life a little easier and flip that second fraction up invert it so that now I can just deal with multiplying instead of division. But I have to flip that second fraction up if I'm going to now do multiplication. Okay, so I flipped it up from the first line. So the numerator denominator flipped. Now I am going to factor out wherever I can. So that one is the difference of squares right there, x plus 2, x minus 2. That one's quadratic equation again, and factor that out. It's these binomials. The bottom part can also be factored as well. Okay, so if you're not good with quadratic equations, now is the time to be good with them from algebra 2. And now we cancel out any similar terms and then clean up your expression. And you should be left with x plus 3 divided by x minus 2 times x plus 1. Okay? So now we are adding and subtracting rational expressions together. So you need to make sure the denominator of these fractions are similar to each other, okay, before you can add them together. Make sense? Just like normal fractions that have numbers. Like, for example, if you did 1/2 plus 1/3 or 1/3, then they both need to have a common denominator, right? And the lowest common denominator or the lowest common multiple is 6, right? And so you would take one top part times 2, the other one times 3. So that's what you're really doing to make the denominators equal. So do the same thing with this expression for part A. Understood? So you have to basically multiply each denominator by the other guy, like this. The first fraction, the top will multiply by x plus 2. And the second fraction, the top will multiply by x minus 1. And then you will have them having similar denominator. And now you can add the terms on the top of both fractions. So basically you multiply them out, add all the similar terms to each other, right? So the x squared would be left alone, add the 3x and the negative x together, and then the 6 would be left alone as well, okay? And then that would be as far as you can take the numerator of this expression. And this should be your final answer for this question. Okay, the next example we have is going to be 1 over x squared minus 1, and then minus 2 over x plus 1 squared. Okay, so make sure we have common denominators. So that first fraction, I just basically factor that out, right? The difference of squares. The second one, I just repeated x plus 1 twice. That's an x plus 1, by the way, x plus 1. Sorry, the handwriting got slipped there. And then basically you will need to make sure the denominators are the same. So to make them become the same, find the lowest common denominator. So you basically will multiply the first fraction by a additional x plus 1. And then the second fraction you multiply by a x minus 1. Then the denominators will be equal to each other. And now you can add the two fractions together and add the top terms of the numerator in both fractions. So now you have this, okay? When you add them all together, the numerator terms, the denominator will still stay like that. And then simplify, add the x's together and add the numbers together. So the x's will come out to negative x and the numbers will come out to 3. And the bottom part will just still be that. And you can sometimes write this instead of negative x plus 3, you can also write it as, 3 minus x, okay? And then the bottom would be the same. So that is then the video for you to watch for today. And so please do the problem set. After you take notes with this, I want you to please do the problem sets here. All right. And then that will be for your assignment. All right, you guys, we'll see you next week. Have a great weekend.